Given a connected acyclic graph with n nodes and n minus 1 edges, count the pair of nodes that are at even distance. Okay, so this node, from node 0 we are having no other nodes. From node 1 we are having an adjacent node 2. From node 1 we are having node to 1 itself and 1 to 3, and from node 3 like we are having a node to node 2. So they are also connected. This is also undirected. So from 0 like we are having nothing. From 1 we are having 1 node to 2. Okay, now from 2 we are having 1 node to 1. Okay, yes, we are having, since it is undirected we can just draw a single line. And from 2 we are having 1 to 3. Okay, we are having 1 to 3. And from 3 we are having 1 to 2. Yes, this. Okay, so what are the pairs? This is a pair, this is a pair, let's use this. This is a pair, this is a pair, and this is a pair. But we don't want all pairs. We need only those pairs that are at even distance. So what is the distance from this node to this node? It's 1. What is the distance from 1 to 3? It's 1, 2. What is the distance from 2 to 3? It's just 1 only. So we are only having this pair which is with the distance 2. So what we consider means we will be considering one node. We can say start. We can consider start as our source node or the starting node. We can try to find the distance from this start node and store it inside an array. Now for index 0 there is nothing. For index 1, what is this having? Let's say it's having what does it have? That node will be having 0 because that's the start node, and our source node to source node is 0 itself. To 2 it's having 1. Okay, and to 3 it's having distance 2. So this is our indexes, and this indexes denotes the nodes. We are having no nodes for adjacent nodes for 0. For 1 we are having 2. For 2 we are having 1 and 3. For 3 we are having 2. Okay, now we need to count like how many nodes are there with even count. So we will be having an even variable, a count variable, an odd count variable. So we don't want to consider this 0 because our node starts from 1 every time. So we start from 1. Okay, only this we need to consider. Is 0 more 2 is equal to 0? Yes, so we have even count 1. Is 1 more 2 is equal to 0? So it's a node, we have 1. Is 2 more 2 is equal to 0? Yes, so we have another 1. So even is 2, odd is 0, odd is 1. So what is the number of, what is the combination that we can make use in order to have a pair? It's NC2, which means n into n minus 1 by 2. Substituting the values for n, in the first case we have 2, so 2 into 2 minus 1 is 1 by 2, which is equal to 1. The other one is 1 into 0 by 2, which is equal to 0. So the answer comes to be 0, and this is only the pair that we are having. Now for the next example, for index 1 we are having 2, 4. Okay, so let's also make it that for index 1 we have 2, 4. For index 2, for node 2 we have 1, 3. Okay, for node 2 we have 1, 3. For node 3 we have 2. So for node 3 we have 2. And for node 4 we have 1, 5. Node 4 we have 1, 5. And for node 5 we have 4. For node 5 we have 4. So let's try to draw the graph and understand it more. So from 1 Okay, we are having adjacent node as 2. We have another adjacent node 4. From node 2 we have one node 1 and other one 2 3. From 3 we have another one back to 2. From 4 we have 1 to 5 and 1 to 1 and 1 to 5. So this is the graph for the given adjacency list. Okay, so let's consider this as our source node. Okay, from 1 what is the distance into 2? Okay, so from 1, so first one will be 0, and from 4 1 also it will be 0. So from 1 what is the distance to 2? It's 1. Okay, it's 1. So from 1 what is the distance to 4? It's also 1. Okay, so let's not consider that, we can go this way. Okay, so from 2 we explore its adjacent node, it's 3, and the previous was 1. So from 1 to this 3 we need to go through this path, and we already have a distance of 1 in order to reach 2, and from 2 to 3 we are considering another distance is 1. So 1 plus 1 which becomes 2. So from 1 to 3 we have a distance of 2. Okay, we are done with this, so we backtrack. So here basically we will be making use of a DFS kind of algorithm where we goes down and down and down, then just backtrack back to the position and still explores the other positions. Okay, so now we backtrack giving the results as 1, we backtrack giving the results as 2. Okay, so we chose 2. Now we again reach 1. Now we go to the other unvisited node. So into this also we are having 1, and to this we need to go through this path. So we already have visitor 1, so here it will be having 2. So 1 2. So now we will be finding what is the number of pairs. Okay, so we have even, odd, and we start from this one. 0 is equal to even, yes, have 1. 1 is equal to even, no, it's odd. Okay, 1 2 even, 1 odd, 2 even. So what's our answer? Our answer is NC2, and we need to consider for both even and odd, and its summation will be the answer, that is even whatever will be the NC2 for even plus NC2 for odd will be the answer. Okay, so NC2, what is NC2 for this one? 3 into 2 by 2, which is equal to 3. What will be those pairs? You want this one, we are having one this one, and we can also have this one also. Like there will be different pairs that will be possible. Okay, so that's why like we are considering both even and both odd, because suppose let's say like we are having 1 2 3 4. Suppose this 1 and 3 is a pair with even distance, and this 2 and 4 is also a pair, and it will be also having an even distance if we consider this as the source. So this also needs to be considered for our answer. That's why we are also considering for the odd. Now for this one we are having an odd count 2, so it will be 2 into 1 by 2, which is equal to 1. So 3 plus 1 is equal to 4 will be the answer here. Yeah, so that's one. A simple depth first search traversal is the way to go. So let's have the initial setup. If boolean is equal to new boolean of n plus 1, because the nodes are starting from 1, and for us 0, we are not having any such nodes, and we need to have our distance array, which is equal to same way int of n plus 1. Okay, now we will be doing the DFS. Since it is connected, we don't want to have a extra loop. We can directly do the DFS starting from 1. DFS graph n visited distance, and from where we are starting. This is the node we are starting, and what is the distance for that? 0. And we will be populating the values inside the distance, and we also need to have int even count, which is equal to 0, int odd count, which is also equal to 0. Now we will be just going through inside the distance array. Okay, and what we are doing, we are just getting the count of how many even and odd distance are found inside. So if dist mod 2 is equal to 0, we are having the even count plus plus, else it is an odd count, so we are having an odd count plus plus. So what is our answer? Our answer is NC2, and this must be applied to both even count and odd count, so it will be even C2 plus odd C2. Okay, versus that combination. So return even, let's do even into even minus 1 by 2. Okay, this is 1 plus odd into odd minus 1 by 2. This is the answer that we are looking for. Now we need to do the main part, where the DFS, where we are doing the DFS. So it's also pretty straightforward. It's the normal DFS function. There is nothing fancy that we are doing here. Okay, integer graph, int n, we have a boolean visited, then we have the distance array, we have the node, we have the current distance. Okay, now let's mark the current node as visited. It's true. Now mark its distance of the node will be whatever be the value inside the current distance. Now consider all the adjacent nodes, let's say children of the current node. So it will be graph dot get of node. So for integer child from children. Okay, if this is not visited, we are moving further downward. DFS graph n visited distance, and our node becomes child, and our distance increases by 1. Okay, so here we are just doing the normal DFS function, and for this DFS the time complexity will be big O of v plus e, where v is the vertices, e are the edges, and for space, like we are having big O of n space for this visited array, big O of n space for the distance array, and if we consider the adjacency list into our space complexity, then we are having an extra space of big O of n plus e, or v plus e. So big O of v plus big O of v plus big O of v plus e will be the total space complexity for the for this problem, for this DFS problem. And also we can just get rid of this distance also, because if we get how many number of v1, like we can also just make a count here. I'm not doing that, but just sharing. If the current distance is 0, we can have some kind of even count here. Okay, and the DFS function we get the even count. So the normal even into even minus 1 by 2 plus the remaining part will be odd. So n minus even will be odd at that case. If we decide to optimize, we can optimize, we can get rid of this space, we can make use of an extra variable in order to get the even count. Okay, and then normally do this point plus for this odd, how many number of odd. If we are having x number of odd, then n minus x number, sorry, if we are having x number of even, then n minus x will be odd. So n minus x into n minus x minus 1 by 2. That addition will give us the same answer. But let's go with this approach, taking extra space. Okay, so that's one kind of an optimization that we can do for this problem. And I have, okay, it's even count outcode. It's a very simple mistake, but must be avoided. Should be avoided. Okay, then we will be good. I get 3. I get 3 into distance, current distance plus 1. If not visited of child, visited of node will be true, distance of node will be current distance. What will be the current distance? Okay, get of node for integer child from children. If not visited of child, then DFS of graph. Okay, where we got missed. Okay, yeah, it's my problem. Here the distance array will be from 0 to n. Okay, so in our case, the 0th index, we are not dealing with the 0, we are not having any 0 node, so that place will be having a value 0. So here it will give the distance as 0. It starts from there. What I means the distance array will look like something like 0, and for node 1 is again 0, for node 2 it's 1, for node 2 2, and our iteration for this loop start from this 0, and this is also in even, so our even count increases by 1. This is also in even, our even count increases 2. This is odd. Okay, now this is even, so our even count becomes 3. So what is 3c2? 3c2 is 3 into 2 by 2, which is equal to 3. That's why we are getting answer as 3 here. So we should not do the thing here. We need to start from I is equal to 1, I less than or equal to n, I plus plus, if distance of I. Now we are starting from node 1. Now we are considering only this one. So if node distance of I mod 2 is equal to 0, then our even count plus plus, else odd count plus plus. This is a silly mistake that everyone might make. I made here. I made it here anyway. Yeah, it's 1 1. This will be correct. So as I told, we are just making use of a simple DFS function. So it will be time complexity will be big O of v plus e, and space complexity will be big O of v plus big O of v plus. If we need to consider, if we consider this adjacency list, then big O of v plus e. And as an optimization, we can get rid of this extra space and can make use of a variable in order to keep track of this even count, and do even count into even count minus 1 by 2, the normal step, plus n minus even count into n minus even count minus 1 by 2, which will give us the remaining odd count. So that's the odd at even distance problem.